Here we are working on day 3 of 4.4 complex zeros and the fundamental theorem. And what we're going to be doing is working through the synthetic division and breaking down the polynomial possibly several times. So we start with this example, and we have x to the fifth minus 2x to the fourth plus 2x to the third minus 4x squared plus x minus 2. We want to do our factors of p, which would be positive and negative 1 and positive and negative 2, which was the factors of the 2. And then factors of q, which is 1, are just going to be the positive and negative 1. So when we look at all the combinations, we get positive and negative 1 and positive and negative 2. And we look at 1 over 1 and 2 over 2. So now we start synthetic division to try to find our zeros. I like to start with the lowest positive whole numbers, so I'm going to start with 1. And I'm going to put in my numbers 1, negative 2, 2, negative 4, 1, negative 2. And I'm going to bring down the 1. 1 times 1 is 1. I'm going to add here, I get negative 1. Multiply by 1, I get negative 1. Add here, I get 1. Multiply that by 1, I get 1. Add here, I get negative 3. 1 times negative 3 is negative 3. Add, I get negative 2. When I multiply, I get negative 2. And when I add, I get negative 4. Now that did not work out as a 0 here, but I'm going to check to see if that was an upper bound or a lower bound. And upper bound would be if all of these are positive. Lower bound would be if these are alternating. So I've got positive, negative, positive, negative, negative, negative. So the fact that I have 3 negatives in a row here, this is not a lower bound and obviously not an upper bound. So I'm just going to cross this out. So then I'm going to move on and try 2. So 2. And I have 1, negative 2, 2, negative 4, 1, negative 2. When I bring down the 1, I multiply, I get 2. I'm going to add here, get 0. 2 times 0 is 0. I'm going to add here and get 2. 2 times 2 is 4. I add, I get 0. 2 times 0, obviously 0. Add here, I get 1. 2 times 1 is 2. Add, I get 0. All right. So my quadratic here is, not my quadratic, I'm sorry, my polynomial is going to be decreasing this exponent of 5 down to x to the fourth. I'm going to decrease by 1. So this is x to the fourth. I'm going to skip the x to the third. I get plus 2x squared. I skip the x, and then I have plus 1. Um, well, that's 3 terms. And the fact that we go from x to the fourth to x squared, this is actually written in quadratic form. So what I could do is I could actually factor this just like I would any other quadratic. So I'm going to have my product and sum. My product value is 1. My sum value is 2. The factors of 1 that add up to 2 would be 1 and 1. And now instead of writing x plus 1 and x plus 1, I'm going to put x squared plus 1 times x squared plus 1. And that's how I get my x to the fourth and then my x squared in the middle. So now I'm going to set each one of these equal to 0. So x squared plus 1 equals 0. I subtract 1. I get x squared equals negative 1. Take the square root of that, and I get x equals positive and negative square root of negative 1. And the square root of negative 1 is I. So I get x equals positive and negative I. Well, I'm going to get the same thing for the other x squared plus 1. And so I don't need to do all the work again. I'm just going to get positive and negative I again. So my zeros are I and negative I. So those are my zeros. Now to create factors from that, I know that I have 2 positive i's and I have 2 negative I. Okay? Now, my zeros are the C value. Those are the zeros. And to create the factors, I'm going to put it in the form of x minus c. So I have I, so that means I have x minus I. Because I have 2 of them, I'm going to put an exponent of 2. And for negative I, that is x minus negative I, but minus a negative makes it plus I. And again, I have 2 of those, and so I will square that. So my factors are x minus I squared times x plus I squared. And that would be the complete factored form of our polynomial. So let's look on to the next example. Here we have p of x equals x to the fourth minus x squared plus 2x plus 2. And hopefully you will realize that you were missing a term here. And we need to fill that in with 0x to the third. So if we do our factors of p, which is 2, over the factors of q, which is 1, we will get the same zeros we had above. 1, positive 1, negative 1, and positive negative 2. So again, I'm going to start out with positive 1. I'm going to fill in my numbers here. 1, 0, negative 1, 2, negative 2, sorry. Nope, that is positive 2. And positive 2 again. So I bring down the 1. 1 times 1 is 1. I add, I get 1. Multiply, I get 1. Here I get 0. 1 times 0 is 0. Add, I get 2. 1 times 2 is 2. Add, I get 4. All right, so now that did not work. This was not a 0. Now, I might be able to justify this as a upper bound, but with that 0 there, it doesn't quite fit the rule of upper bound, of an upper bound. So I'm going to go ahead and try the 2. So this doesn't work, and I'm going to go ahead and try 2. So 1, 0, negative 1, 2, and 2. I bring down the 1, times by 2, I get 2. Add, I get 2. Here I get 4, 3, 6, 8, 16, 18. Nope. And 2 is obviously going to be an upper bound. It didn't work, so we don't have anything larger than that. It doesn't matter. So now I'm going to try negative 1. Negative 1. 1, 0, negative 1, 2, and 2. Bring down the 1. I get negative 1. Negative 1 times 1. Add here, I get negative 1. Multiply here, I get positive 1. Add, I get 0. I get 0 here. Add, I get 2 times negative 1 is negative 2. Add, I get 0. So this is a 0. So we started at x to the fourth. Now this is x to the third minus x squared. Skip the x and then plus 2. And so what we have to do, that's not a factorable polynomial. So we need to try another 0. Well, we only have one other 0 that we could try. So let's go ahead and try negative 2. Now we're not going to go back to the original polynomial here. We're going to start with this new polynomial. I'm going to circle this because that's a 0. And I'm going to write into the box here this new polynomial that has been broken down at least once. So 1, negative 1. I got to fill in for x, so 0, and 2. So if you notice, it's these numbers right here without the remainder. So I'm going to bring down the 1. I get negative 2. I'm going to add. I get negative 3. I'm going to multiply. I get 6. Add. That's 6 times negative 2. That's negative 12. And that's negative 10. Well, that didn't work. And this is a lower bound because we are alternating our signs. So negative 2 is a lower bound. Well, this is very interesting because I went through all my zeros and only one value worked. But I need to break this down one more time. And so what I need to kind of think about here is if 1, positive 2, and negative 2 all were not zeros, the only value that worked was negative 1. So maybe negative 1 is going to work again. So let's try negative 1 again. So 1, negative 1, 0, and 2. So I'm going to bring down the 1, multiply, I get negative 1, bring this down, I get negative 2, multiply, I get 2, add, I get 2, multiply, I get negative 2, add again, and I get 0. So there we go. So negative 1 is being used twice in this problem. And now this final polynomial is a quadratic. And it is not a factorable quadratic. So what I need to do is either use quadratic formula or quad 3. So I'm going to show you using the quadratic formula. So negative b, so opposite of negative 2, plus or minus the square root b squared, so negative 2 squared is 4, minus 4 times a, which is 1, times c, which is 2, all over 2 times a, which is 1. Now I'm going to simplify this. I get 2 plus or minus the square root. Inside the radical here, I have 4 minus 8, which is negative 4. So I'm going to have negative 4 underneath over 2. Square root of negative 4 is 2i because the square root of 4 is 2 and this negative puts an I with that number. So this is 2 plus or minus 2i over 2. And what I need to see is that I have 2 over 2 in both of these terms. So 2 and 2 will cancel down to 1 and 1. And I get 1 plus or minus I. And if I need to write my complete factors, I have negative 1 twice. I have 1 plus I, and I have 1 minus I. So remember, we're subtracting our x's. So this is going to be x minus a negative 1, which is x plus 1. I want to make sure I put a squared on that. I'm subtracting 1 plus I, which means I take x minus 1 plus I in parentheses. I have to distribute that subtraction, and I get x minus 1 minus I. And then for 1 minus I, I'm going to have x minus 1 minus I. I distribute here, and I get x minus 1 plus I. So my complete factored form will be x plus 1 squared times x minus 1 minus I times x minus 1 plus I. My zeros were the two negative ones, the 1 plus I, and the 1 minus I. So as you can see from this problem, we had to work through, we broke this down by finding a 0. We broke that down to x cubed. And then the next time we tried any zeros, we used that new polynomial that was already broken down. And then when we found that 0, we got down to a quadratic, which then we could use other methods to find our zeros. Okay, and we're done.